And anxiety, stress, overthinking, family pressure, and depression can destroy your mental health. And those are the main factor to be committed to suicide. Let's say your brain is just like a city, then depression can bring it to a halt. Obviously, it can bring it to a halt because mental health included our emotional, psychological, and also the social well-being. That's why, according to the Center for the Disease Control Preventions, there was over 48,000, again 48,000, quite a big number, suicide-related death was happening in USA in last year. That's mean in every day 132 people are committed suicide. Now in this tutorial, you're going to see that how can we detect the suicide related content that are posted on Facebook, Instagram, or the Twitter using the machine learning and natural language processing.
Like you, be strong to hold the powers of the sun. To dream, believe in strength. Now I'm the only one, only one. I was an ordinary boy.
In order to detect the suicide and the depression, you're going to collect a data set that's from Kaggle. And this is the data set. And it will actually containing two columns, having the text and also the class. That's mean the suicide or the non-suicide. So using that, we are going to building here our natural language processing model using long short-term memory. That's called the LSTM. So without wasting any time, I'm going to go on my Jupyter notebook and try to do the feature extraction and building the model. And after all, I'm going to testing it out. It allows you to building one web applications using this Streamlit. So without wasting any time, I'm going to start the tutorial now. Well, so right now we are in a Jupyter notebook and we already do the coding part here. And this is the code for that, right? You can also do it in a Google Colab. You can load the file in your Google Colab and you can run it simply, right? So first, what you're going to do, we actually importing all the necessary library that is required to building this application that's called the suicide and the depressions. And for that, you're going to actually using here the natural language processing technique because this is one textual data, right? And we have the one text column and also one class column, right? So let's see the library. First, you input here the NumPy, and because NumPy is a library to doing the multi-dimensional array calculations. That's why I actually imported the NumPy and also the pandas. So pandas is nothing but required to to loading the data set from the directory, right? And already in my directory, it have a folder that's called the society detection.csv inside my working directory, right? And you can see here from sklearn.model selection, you can import here the train, test, and split. And when you're trying to building one machine learning model, you need to divide your data set into two parts. One is the training part and another one is the testing part. So you can also divide in the three part also, like training, testing, and the validation. So that's why actually important here, train, test, and split. So remember one thing that is for the training, you can take the 80% data, and for the testing, you can take the 20% of the data. That's why I imported it. And you can see here from the near neat text dot function, you're going to import it because you need to remove the text like non text or a blank space or the special character that you need to remove them. That's called the clean text or data cleaning part. So for that, you're going to using here there the neat text, right? Then we have the floaty in order to actually visualize the text to that how many text as suicide or how many texts are not a non-suicide kind of text. So that's why I actually imported the plotly. You can also use here the matplotlib also, right? And then you could import here the matrix in order to evaluate. I mean, you actually check the performance of the model. That let's say you are going to building here one LSTM model or the a TF-IDM model or any kind of model. In order to check the performance, you're going to using here the classification report. Where you're going to get the accuracy, the F1 score, blah blah blah, right? All the things, right? Then we have input here the Keras, and Keras is nothing but the backend of the TensorFlow. Then we import here the layers, which will actually require like embedding layer and the dance layer, the LSTM, the global max pooling 1D, and the input layer, right? This is nothing but input layer, how you need to pass here your data. And we also input here the callbacks to early stopping that. Let's say I'm going to give here epochs as the 100 epochs. Now in the 20 or 30 epochs, my model is working very really fine. So this time it actually stopped them into like stop the executions. So that's why actually using here the early stopping and also the reduce LRO plotting, right? And also import here the sequential model. So there are two types of model actually available in the machine learning. One is sequential model. I mean, machine learning means the Keras library, and the sequential layer, and also one functional API. I mean, function types of models. You can also be that. Then you have import here the TensorFlow. You need that it TensorFlow import TensorFlow as a TF. Then import here the label encoder. You need to one hot encoding. I mean, label the all the data into between 0 to 1, and actually import here the tokenizer, to make it token, because you're using here the LSTM. So that's why I need to convert them the textual data into one number of sequences. That's why I actually import the keras.preprocessing.sequence input the pat sequence. So TQDM is nothing but one library where you could see the processing part, how many file are loading in a processing part. That's it, right? So what you do here, you actually import here our data set. So you can run it from here, or you can also use here the shift enter on your keyboard, right? Then you can see here the suicide detection.csv that's already available inside my directory. So that's why I actually pass here my path of that. And what I'm going to do, you can simply run it here. In order to show the head, it actually show the five row of the data set. Okay. Then what I can do, we have one text. This is nothing but my text, and based on the text, we are going to classify that this is a suicidal text or the non-suicidal text. Then we are going to count that how many data are actually available here. It is imbalanced data or the balanced data. I see that's are mostly balanced and all have the similar types of suicidal text and the non-suicidal text. That's really balanced data. So you don't need to actually do the handling the missing value or the imbalanced kind of data, right? So then we can do checking for the index and how many classes are available, suicide and the non-suicide, two classes are available, right? Then what I can do, we can simply divide our data into train, test, and split, right? Train, test, and split, because to building the model, obviously 80% for the training side and 20% for the testing side. So that's why actually divide them into the 80 by 20. Then what I can do, we can simply counting for again the training data, and training data must have the two classes, suicide and the non-suicide. That means it should divide all the data in the same kind of way, 80% to 20%. That's why actually checking this out, the it will sharpen in the data or not. Then what I can do, you can simply visualize it. We can simply visualize it. See, so we have the value for the non-suicide, and this is for the suicide. I have more than 90k plus, right? 90k plus data available inside our data set. 92.831k data set available here. Okay, that's good. Now it's the part for the data cleaning, because you're going to pass the data inside our model. So that's why you need to also clean the data. So data cleaning means removing the special character and remove the stop words, and just paste it inside one list, right? That's called the data cleaning. So why should you need to do the data cleaning part? Because there are some unnecessary part actually here. It actually uh, giving some problem in order to building the model, right? So I need actually tokenize your data. So that's why we do the cleaning part, and we define here on function which will actually help us to clean the data. Then you're going to actually give here to empty list, one for the text length and also another one the clean text. Text length is nothing but my counting the length of the text, and also the clean text is nothing but taking all the textual in a clean format, having no special character, the stop words, and the blah blah blah, right? All them. So first, what you can do, you can simply convert our text into lowercase letter, because it has having uppercase letter, or see you can say uppercase letter. We're going to make this in a single word. I mean, in a single form, like lowercase letter, right? And then you're going to remove the special character using my nfx library. I mean, neat text. If I go up, you can see the neat text dot function. You can import here the nfx. So that's why actually using this one. Then you have the remove the stop words and append it inside my text len. Text len means how many texts are inside the data set. It will help us to predict that, and I need to actually pass this inside my model, so that model can know that this is a text len, this is my clean text. So that's how you append it, right? Then what I can do, you can simply pass my training text data and also the test state data, because we actually already divide the data set into train, test, and split. So that's why I need to also clean the data, right? You can also do it in the first, and after that you can also divide it. It's up to you. But I first actually make it train, test, split, and after that actually divide them and also clean the data, right? So this is for the cleaning the data. You can also use the shift enter keyboard from the keyboard to clean that. So I'll call in these functions and clean text data and passed it the two variables. Let's call the clean train text and the train text length, right? It will actually give me. So you can see here it having the more than 18,000, right? More data, right? And it will be processing them. And this is happening because of the TQDM. You can see here it passes the TQDM function inside our text, which one actually iterates all the value inside the text. So that's why actually using here the TQDM. If you don't use the TQDM, you just see like the star button, it will run in the shell again and again. So you don't have the idea the how in the shell is actually running. Now you can see here it's working pretty fine. Then what I can do, we can simply divide them data into some kind of token. Let's say I have a word, I'm Chandu, right? It actually making the token like I and the M and the Chandu. It converted into the token. Then what I can do, you can simply feed into the text. You can also see it. Let's say I'm going to see the tokenizer. So if I run it, so this is nothing but one a tokenizer uh, functions. If I try to see the clean text, and if I try to run this one, and you can see here this is look like that. Hey, east coast, yeah guys, doing what? Something like, or it actually removing all the word, all the special character and convert it into the uh train test split, and it actually convert them into tokenizer. It mean it actually remove the duplicate value also, right? So that's why this tax is looks like that, and inside one list, right? Now what you can do, you can simply convert this text as into the sequences, right? So how can you do that? You can use here the text to sequences from the tokenizer and also convert them into patch sequence, because you're going to pass it inside my um, I'm going to pass this inside my LSTM model. So that's why you need to make it in the sequences. So this is the code for that. And what you need to do, you need to do the same things for our training set and also the testing set. So you can see tokenizer.text.sequences. We actually do it for the clean text, and we need to pass train text sequence inside my pat sequence. Now I need to give here on the maximum length, then how many length it will take in order to training your model. I mean, maximum length of your token. Let's say I pass the 50. That's my capacity to load it in my GPU. You can give here the 5,000. You can give here the 10,000 based on your uh, based on your system requirement. You can actually give it, right? Then we're going to pass the same things for the text sequence also, and maximum line should be 50, right? Now what you can do, you can simply run it. So it actually, what it will do, it actually convert them text it into the sequences based on my uh, LSTM model. You can also check this out. Okay, let's take a few time to actually convert them into the sequences and also the pad sequences. Then you can see it, right? Well, it's running, working fine, and I'm going to copy this out. And let's try to see the sequence first. Okay, this is nothing but a sequence and having the some number. That's means actually convert them texted into some kind of number so that it can correctly identify or pre-process the data. Because actually, the computer doesn't know the textual data; it actually convert them into the numbers. So if I try to check the pattern, the pad sequences, it will also want a number array list, right? So that's really fine. Now we need to using here one technique for the convert the word in the vector. That's called the word to back. But in this case, you can using here the globe embedding, the new one. You can use the word to back. You can use the TFIDI vector or the bag of words. But the globe embedding is another way to convert your text into the vector. So what is actually globe? So globe is nothing but a global vector for word representations, and it's an alternate method to create the word embedding in order to embed your word. So it's actually based on a matrix factorization technique on the word context matrix. It actually working like that. It's just like a matrix to actually working on a large kind of matrices. So you can use here one pretend model also, but the problem is why should you actually using the pretend model? Let's say I have one real application. We train our model over, let's say, Wikipedia text or the Twitter text with a window size around 5 to 10. Let's say we have a window size of 5 to 10. So the number of word corpus, because word embedding is nothing but on corpus, right? So it will maybe have the parameter of the 30 millions. So in order to training this model, it will take more than 5 to 10 days. Obviously, 5 to 10 days. So this is quite time consuming, right? Obviously, this is the time consuming. So hence, it's take a huge amount of time, obviously. So to avoid this, we can use the pre-trained word vector that already trained, and we can easily use them. Yes, we can easily use them. And I'm going to use this also. That's called the globe 8 for b dot 300 dot pickle file. So how you actually get this pickle file? Yes, you can get this pickle file in a Kaggle also, or there have a one website from the Stanford. You can also use them because the globe is actually building for the Stanford. That's why you can use it. But in a Stanford website, actually using this in a text format. So after that, you need to also convert them into pickle file. But in the Kaggle, you can get it the easily in a pickle file format. So let's go on here, right? So this is the pickle file for the globe.840b.300d, and this is the pre-trained model, and it's around the 3 GB, right? And if I go here, this is nothing but my actual one, and you can also download it. But the problem is it actually gave you in a textual format .txt as extensions. You need to also convert them into the pickle format. So that's why the Kaggle one should be the better one, right? And here you can get the file in the pickle format. So that's why I'm going to using it, and it's quite easy to load the model. Well, so one more thing that when you do the globe embeddings, make sure you need to do the label encoder first. Label encoder is nothing but actually converting your data into between 0 to 1, right? Between 0 to 1. So what you need to do, you need to pass your data inside of the label encoder. And after that, it is the label encoder. And after that, you can load your pickle file. So how we actually load the pickle file? We actually imported the pickle, right? And with open globe.832 300 pickle file and the RB mode. RB means that's mean read mode. If you're trying to read it, you can give here the RB. If you try to write it, you can give here the WB, like that, as a file. And now you're going to import it. I mean, you're going to load it in our Jupyter notebook. So make sure that your file is available inside your working directory, right? Then what you can do, we can simply do the word embedding, I mean label encoder. Then we're going to load the our globe embeddings that we actually downloaded from the Kaggle. So it will take few seconds to actually load it because it's quite big file, like 3 files, and also P10 model. So where it's load the pickle file in our Jupyter notebook. Now what you can do, we can simply convert them into the embedded matrix. Why? Because these globe embedding actually working based on the matrix factorization technique on the word context. So that's why you need to convert them into the embedding matrix. Then you need to also calculate the length of the tokenizer.word index, because you need to pass it inside my embedding layer. When you're going to building here our sequential model. Then what I can do, you can simply actually create here on the np.zeros of the embedding matrix, and you're going to pass it all the value from the token, right? From the token, right? You can see on the tokenizer.whatindex.item, you're going to getting all the value from here. I did to all the value from here and make one embedding vector. If I try to check the embedding vectors, let's try to run it and go for another shell. Okay, and if I try to check the embedding vector or embedding matrix, let's see the embedding matrix, then you can see it correctly. So this is a matrix having the zero, it actually containing inside by 0 to 1, because we already do the label encoder, and it's actually creating one embedding vector for that, embedding vector for that of the word representation. So that's why actually first convert them into vector, and after that, if the vector is not a none, then we're going to pass the value inside our matrix. The empty matrix having the zero. That means actually replacing the zero with the vector value. If the value is not available, that's what actually make it as a zero. That this is how actually globe embedding actually work, right? Quite simple. Then we're going to initialize here the earliest stopping, because let's say we have epochs of 100. We're going to train our model using our 100 epochs. So after 20 to 30 epochs, our model actually working fine. I mean, accuracy is really very fine and loss is reduces. So this time we're going to stop it. We're going to stop it. But how can I stop it? Using the early stopping. It will automatically stop the execution on the program, right? If you're using Jupyter Notebook, it will stop the kernel, I mean the executions, and like in the Google Colab also, right? So let's say I run it. Then you're going to do the model creation using the Keras sequential model. So there are two types of model, and I already discussed about that. One is the sequential model, which will pass the data from the one layer to another layer, and another one is the functional model, right? So we actually import here the model equal to sequential, initialize it, and add here the input shape with the 40. That's when you can pass the 40 length of word, right? You can also increase it based on your requirement, right? Then what I can do, you can pass here my embedding layer b plus 1. B plus 1 is nothing but my length of the token. How many what are available inside my token index, and we need to also pass here my matrix, embedding matrix, because these globe embedding actually working to do the matrix factorization. That's why you need to pass here my embedding matrix, and trainable parameter should be false because this model is already trained in the few kind of order, but we're going to train it in our new kind of data, so that's why we make the trainable should be false, right? For this data, because this is a new data, and where maybe this kind of data is not available, and globe is right now the pretend model, so that's why we make this trainable should be false. Well, then I'm going to pass here my LSTM layer, LSTM equal to 20, okay, kernel size, and recurrent sequence equal to 2. Because LSTM is one kind of RNN which will actually learning from their past experience. I mean, usually give the data into the past experience and store it into the memory. So that's why you going to initialize the return sequences equal to true. Then you're going to give here the global max polling 1D. So it's actually nothing but one uh, pooling types of operation where it actually downsampling the input representation by taking the maximum value over the time dimensions, right? And we actually reduce the data based on my time dimensions. Then I'm going to pass here my dance layer and dance layer one. One is nothing but my output layer. This is my input layer. That's mean this is suicidal text or the non-suicidal text like that. And activation function is obviously sigmoid because this is one binary classifications. That's why sigmoid. Otherwise, it should be the shockbacks, right? But before building the model, you need to also compile it. We need to also compile it. So for that model.compile, and we're going to give here the optimizer that's called keras.optimizer.sgd. That's one gradient descent algorithm. As mean stochastics gradient descent algorithm. We need to also pass the momentum, and pass the momentum should be 0.09, and zero point 0.1 is nothing but my learning rate, right? And we have by loss is binary cross entropy. Why? Because this is one binary classification problem. That's why we pass by loss as a binary cross entropy. Then you have the matrix, and matrix is obviously accuracy matrix. Now what you can do, you can simply shift enter, and you can see the model summary also, how many parameter are actually available. You can see here we give here the 40, and see after global max pooling 1 day, it will actually reduce, I mean downsampling the data, the input representation, and it should take the maximum data from here and over the time dimensions, right? Then you have the dance layer and total timer parameter and the terminal parameter, the non-trainable parameter. Now it's time to actually train our model. So for that, you're going to using the model.fit, and you pass here my train pad text sequence, also the training output, the validation data. In the validation data, actually using here the my text one, text pad, and the text output, and epochs is 20. Batch size I give here the 256. You can make it 64, you can make it 32. 256 nothing but it should taking the 256 word in a single, I mean the single epochs, it should do that. And you can do pass my callbacks. My callbacks is nothing but my algo stopping. All right, now what I can do, you can simply done it. So it will take a few seconds or few times or few minutes in order to train the model, right? So i'll I'll back after when the model training is done, right? It will take maybe 20 minutes, around 20 minutes maybe, right? So I'll back after the 20 minutes later on. Then you're going to do the check the testing data classification report, that the accuracy, the F1 score, and all the things. Then we're also testing out in a real time data, I mean real world data, that in the real world data it is really working fine or not. Then after that, you're going to building here one web applications using Streamlit. You can also build it using Flux. It's up to you, right? Well, so you can see here after the 14 epochs, it actually stopped the executions, and we got here the 94% accuracy, and the validation accuracy is nothing but the 0.9314, and loss also decreases. So that's why it actually stopped the executions after the 14 epochs. So that's why actually using the early stopping as a callback. Then what I can do, you can check for the your classification report. How are you going to get your precision, recall, the F1 score, and also support. So I'm going to run it, shift enter. So we're actually getting it for the testing data and also the training data. So for that, I need to give here my test output and also the predict classes. So one more thing, the predict classes. If you're trying to using here my same version that I'm actually using, it will actually work on your case. Otherwise, the predict classes is not working on your cases. That's mean this part is not working on your cases if you're not using my same version that I am actually using here. So if I am open it, let's say Windows R, and I'm going to import here my Python and also check that my version, what version actually you're using here, right? So further, I'm going to type here the Python, and I'm going to import here the TensorFlow as TF, and for checking the version of the TensorFlow. And I'm going to also import the Keras because you need to also know my Keras version, which version that actually using. Because in some cases you actually get this kind of error that sequential object has no attribute, but it classes blah blah like that, right? It will actually importing here the TensorFlow right now. It will take few seconds to load it because it is loading in our code also. So that's why. Okay, it loaded. So now I'm going to check the for tf dot underscore version. So my TensorFlow version is nothing but called 2.3.0. And let's check for the Keras version. Let's import here the Keras. Import Keras. Let's say Keras dot underscore version. Well, so make sure you use here the tier version is a 2.3.0 and the Keras version is nothing but 2.4.3. So make sure you actually install those version that it will working fine in your case. So you can see here, you actually get here my precisions that 0.90%, that's really working fine. And the accuracy is 93%. Really very great. And for the training data, it's 0.94. That's really work fine. Right, so this is my classification report. If you do for the research purpose, I mean, you are writing any research paper or doing it for the final year projects, you can actually use it, right? So then what I can do, we can let's test it out in a unseen data. Though this past year, thought of suicide, fear, and anxiety, I am so close to my limit. So 95% the probability that this is one potential suicide post, right? So let's say I'm going to give here another text. Let's say I will kill myself, right? So this is also one potential suicide post. It 86% probability that. So let's say I am happy. So it's 0.36%. It's not a non-suicide kind of post, right? Okay, we need to make it else, not like that. Okay, shift enter. Okay, it's a non-suicide post, right? So I am happy. So it actually make it a tokenizer and also make it pad sequences because this is one LSTM model. And to pass here, my maximum length should be 50 because if I go up, you can see here we give here the maximum number of land should be the 50. So that's why you need to also do it. How you do the pad sequences, and after that we are going to dump it, right? So for that, what I can do, we can simply shift enter to save the tokenizer and also save the model file, the LSTM model. You can also load it like this way. So how can you load it? Simple picker.load it, pass here my open and the Keras models. You can load it and then we can actually test it out in our data. Let's say you don't need to train the model again and again if you have the tokenizer file and also the model file. So it is a potential suicide post, right? So let's go on the folder directory and see that the tokenizer form and also model file is generated or not, right? Obviously generated because I already loaded it, right? So well, you can see here the model file is also generated, the tokenizer file, and you can see here the globe.840b.300.pkl file, right? So now what I can do, I'm going to open my BS code, and you can see here this is the code for the Streamlit web applications, and how are you going to do the coding bird here, and you can see here this is my nothing but my Jupyter notebook that you see earlier, right? So now what you can do, let's go on the app.py. First, you can import here the Streamlit, to building here on Streamlit applications. Then you input here pickle because you need to load here my tokenizer file. It's in a pickle format, so that's why. Then to import here the from keras.preprocessing.sequence, import the pad sequences, because this is one LSTM model. So in order to load them, I need to also convert my input tags into the pad sequences in order to pass inside my model file. So if I go here, you can see here, this is nothing but my LSTM model, right? So you can see this is my pad sequences. Here it is go pad sequences. That's when you need to do the same thing for that. Then you input here the plotly dot expressed as a px that you see the earlier in my demo video. We actually plotting one probability bar, so that's why you input here the plotly. Then you input here the pandas, because you need to save this data inside one data frame so that you can show it in a bar. So that's why you actually import here the pandas. Then you're going to import, I mean, loading here about pickle file that's available inside my working directory, the took another file, and also the model file. The model file is nothing but my Keras model. That's why I import here the load model, and we pass here my model.is5. Then pickle.load, you open it to another.pickle rb. Rb is nothing but a read mode, because you're going to read it inside my directory. If you're trying to write it, that's if you're trying to save your model in a pickle format, you have to pass here wb. That means write mode. Now it's a read mode, so it should be the rb. Well, then you're going to call here one main functions, and you give here st.title my suicidal post detection app. Then add here one subheader, input the post content below. Then you're going to taking one text input from the users. So st.text input, you're going to enter your post content here, and this is nothing but my sentence, right? My sentence. How are you going to predict it? Then you're going to actually create here one button, st.button predict. And when any user clicking on this button, that's when if the predict button it's true, then what you can do, you can actually st.write the post that actually do it. So it's marking by my post. So as to the right, it'll post equal to sentences, and you're going to pass here my sentences in a list, because this is one matrix factorization technique. Then you're going to pass it inside my pad sequences, text to sequences. Then after that, you're going to convert them into the pad sequences in the length of 50. Why 50? If I go on here, you can see here the maximum length should be 50. That we actually building the model. While building the model, it should pass here the max length should be 50. That's why. Then you predict the sentiment, I mean, predict the suicidal or the non-suicidal technique. So this is nothing but called the ideation, right? You can do it like that way. Then you're going to predict it, and we pass here my TWT, my text. Then you see here the 00 and the printed prediction. If the prediction is greater than 0.5, it is a potential suicidal post. Otherwise, it's not a non-suicidal post. Then this is the code for actually showing the bar, right? Showing the bar. So you can see here actually multiply with 100. Let's say it usually keep the prediction as a 0.98, like this way, 0.98. So if I multiply it by 100, obviously to 98%, like this way. I mean 98% probability that this is one suicidal post. This is not a non-suicidal post, like this one. So that's why actually multiply it with the 100. This is for the potential suicidal post, and you're going to minus it from the 100. Let's say this is 98%, so this is obviously 2%, right? So that's why you minus it from the 100 to prediction minus 100. So that's mean this is non-suicidal, no suicidal post. Then what you can do, you can create one the probability dictionary, how you're actually saving here my class level and also my prediction probability. So don't worry on the code, you'll get this code link in the video descriptions, and you can grab it from here. So this is the main part, and this is the optional one. This is the optional, you can grab it, you can copy it, right? So now what you can do, you can simply go on here and go on the terminal and try to run the code. So you need to run in the code. The command should be streamlit run app.py, right? So streamlit run app.py. Okay, so now I'm going to click here the local URL. So it will open in your web browser, the local web browsers. So in my case, by default is a Brave, right? So now what I can do, enter your post content here. So let's go in the full screen mode right now. And it's better you can go on here and click on the setting, and let's say go on the white mode and run a save like this way, right? So now you need to give here one post, enter your post content here. Let's say I will kill myself. Okay, so you can also enter to apply it, or you can also click here the predict button. So let's click on the predict button, and it will take few seconds to predict it, right? Because it is loading here my tokenizer and also my model. So this is one potential suicide post, and you can see the LSTM plus globe model predict that this is higher 86% probability that the post context is a potential suicide post compared to the 13% probability to being non-suicide post. That means this is a potential suicide post. You can see here, this is one graph. So we actually do it using the pd dot, I mean the pandas, and we loot it simply the plotly, right? So uh, this is the graph for that. So I'm going to use here another one. Let's use here post I will kill myself. So I'm going to using this one. Let's go on. I need help, just help me, I'm crying. So let's use this one, predict, and let's check this out, the it is the potential suicide post or not. Okay, I need help, just help me, I'm crying so hard. So this is the potential suicide post. The LSTM plus globe model predict that there is a higher 96%, 96% accuracy, that I mean probability that this is a potential suicide post. So this is how it actually work. You can also use it in your final year projects. That's really great idea. So let's have a use this one. I have nothing to live for my life. Okay, live for my life is so bleak, right? I'm going to click it to predict it, right? And we also try to do it for the non-suicidal post also. I have nothing to live for, my life is to bleak. Okay, it's 85% accuracy that this is a potential a suicidal post. And you can see a potential suicide post and the non-suicide post. So let's give here one non-suicide post. Let's say I am so happy today. Let's say have a chill. Okay, I'm going to predict it. And let's check this out. This is a suicidal post or the non-suicidal post. So I am so happy today, and it's a non-suicide post. Your post context is rather abstract. The LSTM plus globe model predict that almost equal 1%, just 1% probability that this post contains a potential suicide post, compared to 98% probability that's of being the non-suicide post, right? So this is how it actually works. So that's it for today now. Hope you enjoyed this tutorial, and make sure to subscribe to the channels, and don't forget to hit the bell icon. And I'll be back with the tutorial. So till then, take care and bye bye.